Hi guys, welcome to tonight's videos. We're going to cover friction first. So, easiest way to remember the equation for friction is fun. So this is the force of friction. This is the coefficient of friction. And this is the normal force. So remember, the normal force is the perpendicular force to a surface. This is the force that is keeping the paper from passing through the table. So as you sit on your chair, there's you have your weight on your chair, and this is the normal force, which is equal and opposite. Now you can also have normal forces that are at an angle. So if I have a box on an incline, I'm going to have weight here, and perpendicular to the surface is the normal force. So it points out at an angle. Now here it's not exactly equal and opposite to weight. Here is the normal force here. I'm going to have breakdown of weight. So I'm going to have weight in the y direction. We're going to consider this axis the y direction, and the horizontal to the plane the x direction. So that means that this is weight in the x direction. So this is why our box will slide down, because there is some weight here, and it won't slide down as fast as during a free fall because some of the weight has been dissipated in the y direction. We'll have plenty of practice with this. So the next part of our equation is the coefficient of friction here. It is dimensionless. So this is the Greek letter mu. That's mu and mu. And it depends on three things: the material of the object, the material of the surface, and the type of motion. So you'll get infinite amount of numbers depending on how these three characteristics relate. So on to the three types of coefficients. So the first one is mu s, and this is the static coefficient. Easy, fast enough. Static friction is the most complicated. It depends directly on the forces opposing static friction. So I'm going to write that down. And static friction can have any value from 0, with 0 newtons, to the max, which is equal to, let me do a semicolon, Fs max sorry, no, no arrow on the top. Static friction can have any value from 0 to the max, when the max is mu s times the normal force. The next type is kinetic. And we calculate this kinetic friction by mu k n. Always know that mu k is less than mu s. And you can see how this plays out in the graph on page 134. I'll recreate it here. Here we have our increasing value, and this is Fs is equal to the sum of all the other forces acting against it. So, and then it'll suddenly drop down, and that will be our force of kinetic friction. So if I'm pushing and pushing and pushing on a box and it's not moving, the harder I push, the harder static friction pushes against me until a point. And that point is mu s n. Once I get to that point, it becomes a lot easier to maintain the motion on that box. And the last type of friction is rolling friction. And it's mu r. And then for all of these, the reason why we haven't been putting arrows on the top is because you have to know that the direction of friction, no matter the type, all types of friction, are the exact opposite of the direction of motion. Okay? So those are the types of friction, and we'll have plenty of practice with those in class. And I will see you in the other video discussing drag.